I haven't uploaded in a while because I've been not home. That's basically it. But I've been doing a lot in the meantime. In fact, I've been doing a lot. I've been working on a website in Leptos in Rust. Why? Because I hate myself. I thought it'd be good fun and like cool because, you know, Rust, I like Rust a fair bit, and I don't love JavaScript or web dev in general. So I thought, you know, if I do it in Rust, then it'd be a lot more fun, a lot more Rust-like. And turns out Leptos kind of abuses macros to make Rust seem like TypeScript in a way, and that kind of sucks. So whatever. But you know, whatever, I'm doing it, and we'll see how far I get. But the website in particular is a portfolio that I'm working on. So that's that. Have I been doing anything else? I think that's kind of all I've been working on, actually. I released a blog post I did on Nim as well, on Nim and Odin, but mostly on Nim, because I did my snake project in Nim, which I think I already showed, right? Oh, I didn't. Shit. Yeah, so, okay, well I made snake in Nim, by the way. I made a video about tic-tac-toe and Pong and Odin, but I didn't do my Nim one. But yeah, I made snake in Nim. I might make a video showcasing it at some point, although there really isn't much to showcase. If you're interested, just go read the blog post. It's on kojobailey.me. So just type kojobailey.me. And it's this one here. And it's like a 17-minute read where I talk about my experience with Nim. And you know what? If you've never used Nim before yourself, then I suggest you go give it a read, because you might find it interesting. Sorry, here it is. kojobailey.me. And you might learn something interesting about Nim and its syntax, and because it's quite interesting. I don't love Nim. It definitely has some like flaws that will stop me from using it in the future, but it is certainly very interesting, and tries a lot of different things that I haven't seen other languages try before. So yeah, that was cool. But today I want to do a look at this language called Gleam. By the way, this lighting sucks. Let me just turn the lamp on behind me. Yeah, I think that's going to do like nothing. But anyway, there's this language called Gleam, which came up on my YouTube Shorts feed today, because I've been starting to watch YouTube Shorts in the past like 2 days, because I got like a bunch of like Superman, I think Smallville or something like that, shorts. And then that led to me getting just shorts in general. And one of them was, 4 languages you've never heard of. And one of them was Gleam, which is indeed a language I've never heard of. And Gleam is seems quite interesting. And right afterwards, I got this video recommended to me, like to my feed. This one, which is comparing 10 programming languages. And this one, right now, he's talking about Gleam here, right? He's also talking about Gleam. And then I was in the C++ Discord server, and someone mentioned Gleam, and then I actually don't know what I did. Yeah, here. From the video I mentioned this, because Gleam does not have if statements, fun fact. Gleam instead has just a match. So instead of doing if, and then you have a true or false, right? It just does case true or false, which is quite interesting. And it makes things, you know, it reduces complexity. Well, not like complexity, but it reduces the size of the language in terms of like the number of features it has. So I find that quite interesting. Because in general, I've been looking for ways, or thinking about ways to simplify and unify similar patterns in code. So like one of them is, you know, if you can do an if else with a match statement, why do you need an if else? And if you can, I don't know, or like for example, with function parameters, you could think of function parameters as just a nameless struct, right? And then if we gave that struct a name, you know, and just treated it as a struct, then we would unlock a feature where suddenly you can, you know, declare a struct that is the input for a function, and then pass that struct directly to the function. And that could be interesting, right? Maybe that would unlock some new things. Maybe it would, you know, unlock a new way of programming altogether, where functions are built around taking structs rather than taking just like, you know, like an arbitrary, I mean, not arbitrary, but like just like a a one-time list of parameters. So yeah, maybe there's something interesting there. It would also allow you to reuse the same function parameters very easily, right? Because then you can save those function parameters into a struct. So like ideas like these, right? Where unifying things, but in a way that makes them more featureful. Not necessarily because you're adding a new feature, but because you're combining one thing with a more robust thing, and then just replacing that, so then you get the more robust thing altogether, if that makes sense. It's very, very interesting, but that's basically what kind of caught my attention with Gleam. So I want to have a look at Gleam now, and yeah, kind of do like a deep dive. I mean, not a deep dive, because I'm probably not going to install it, but I'm going to read it. So this is Gleam. The website's gleam.run, and already it looks sick. Like, I love that the star does that. I love the rainbow background. It just seems very... Like, I like when I go to a programming language website, and it looks like it has character, you know? As opposed to being like some AI-generated thing. But Gleam is a friendly language for building type-safe systems that scale. Now, scaling is very important. If I were to list every language I can think of that scales well, I would have a very small list, right? Like Python scales horribly because it's a scripting language. Lua scales horrifically. I don't know how Balacho was written in Lua. That's quite impressive. C++ can scale well, but like if you have basic design flaws, it's very easy, and like you don't like handle safety properly, and you lean into like, I mean, it's C++, right? So like if you use bad practices, you use bad practices, and you suffer as a result. Just make sure my mic's working. But if you use it well, then it should scale as well as anything really, like Java, you know, like Java scales fairly well, and that's why it's used in so much enterprise applications. Although I'm not a huge fan of Java in of itself, I can appreciate that it scales well, as is like C#, which is why C# is used for Unity, right? And also for GUI applications. And C++, you know, can look a lot like C# and Java, but just with more, well, without the garbage collector really. And I guess some more modern features like errors as value, stuff like that. But like you can do that in C++, so that scales well. Rust should scale well, I believe. I guess a bigger issue for C++ and Rust with scaling is actually compile times, but that's another thing. But anyway, then you have like languages like Zig, languages like Nim, like Odin, which are, in my opinion, they're too C-like. Because I don't think C scales particularly well. Because yes, it's nice to have like to know what's going on, right? Like to have your explicit behavior and everything like that. No RAI, no hidden like hidden behavior, or like hidden control flow. That's fine and dandy until you have an application that's like actually quite big, and you would appreciate having the abstraction over the application to know what's going on. So to that extent, I feel like it does not scale well. C, and by extension Zig, Odin, and Nim, which for some reason hold on quite tightly to C. I know Odin is like OOP, but it's not even the good version of OOP. Like it has inheritance as opposed to like a trait system. But anyway, so when I see a language that says, you know, it scales, type safe and it scales, that's quite interesting and definitely speaks to me. So the power of a type system, the expensiveness of functional programming, and the reliability of the highly concurrent, fault-tolerant Erlang runtime with a familiar modern syntax. Now, I've not ever learned Erlang or even really looked at Erlang, but it's cool that it uses the Erlang runtime. An existing one, I should say. Import statement looks like, I think, Nim, import gleam/io, and then you have your pump function main, like Rust, io.println. This is also reminiscent of either Nim or Odin. I can't remember right now. And no semicolons, which is awesome. But it does, I can't tell if it uses significant white space. It might enforce significant white space without actually necessarily making use of it. So that would be interesting too. Supported by Williams and Holmes. Okay. I don't know what that is. End-to-end, I don't know what that is either. Okay. Yeah, so like already this looks quite nice. This kind of syntax is what got me like interested in Nim in the first place, and like Odin. I don't like expect anything crazy from this. Like for the record, when I look at these languages, I'm not looking for like the next language I'm going to use forever. I'm just looking at ideas, because I think it's really important that we keep making programming languages just to simply test out ideas and see what works and what doesn't work. And if it doesn't work, then we abandon ship and make a new language, as opposed to trying to just like, I don't know, to turn it into a mainstream thing. Because like we have enough mainstream languages already, and like Rust, like I've accepted that Rust is less looking now to improve and more to, I mean, obviously it will improve, but like to like redesign, like less focused on research and more focused on having a language that works and can be used for like stuff, right? To kind of replace C++, which is fine, but you know, I would wish as well for it to be a language like Rust that is more for that's more experimental, so that we can get a better language in Rust. I do believe that a better language in Rust will come in the fairly foreseeable future, like near future, and replace Rust. Before Rust even becomes like too embedded. Like the reason that C++ is so hard to replace, aside from it just being a pretty good language, you know, like for all the fuck it gets, it is actually a really good language in comparison to other alternatives. And a reason that it's so hard to replace, besides that, is that you have decades of infrastructure that is built in C++. Rust doesn't have that yet. And with how languages are evolving all the time right now, and like people are constantly creating new languages, how Zig is already competing with Rust. I mean, indirectly, because like it's not really meant to, like wasn't trying to, but like it just has entered the space where people are interested in those kind of languages. So you know, like naturally, it has ended up competing with Rust. And there are other languages too, I think, although I can't name any running off the top of my head. I'm not going to say that Odin and Nim are even in the same ballpark, but because Rust is new, and yeah, I think the chances of Rust being replaced are a lot easier than C++, which is cool. I like that. Although long-time dedicated Rust programmers might not like that. Anyway, let's read on. So reliable and scalable. Running on the battle-tested Erlang virtual machine. Let me do a quick search here. Okay, so Erlang is actually a functional programming language, which is interesting. Because like you have like Scala, right? Or Scala, however you pronounce it, which runs on the JVM. But Scala is functional, whereas Java is imperative, right? Here we have Erlang, which is functional, and then this language, Gleam, seems to be, it seems to be imperative. And on that note, actually, I've been thinking recently about whether pure imperative or pure functional is actually better. I mean, obviously you can like have functional style code in imperative languages, and you can mimic procedural code in functional languages. But I feel like functional might, like if you can find a really good way to do functional, I feel like it could just be vastly better than procedural, just because of the pure compiler optimization potential. So that's quite interesting. Erlang looks, I mean, the issue with functional languages is that like they all kind of blend together, and like because like the functional paradigm is so strict that it kind of becomes a game of like which language has a better syntax and more features. Like Haskell probably wins that still somehow, or like maybe like OCaml, but like I don't know. Whereas like with imperative programming, there's a lot more you can do, because it's not like people call it imperative versus functional, but like really imperative, you can kind of do whatever you want. Like there's no strict rule there. It's just like the default language, like style people have gone for, like C-like. Like you can support functional code in imperative languages, whereas in functional languages, you can't really. You could emulate it, you know, using like special like do syntax or like the let syntax in OCaml, but like that's not really imperative code. Like it looks imperative-ish, but like it's not really. And like control flow is still limited with like if statements and stuff like that usually. And anything that doesn't do that is just syntactic sugar. So like under the hood, it's still functional. In fact, I believe the AST, the abstract syntax tree for Rust, is actually functional, funnily enough. So Rust itself isn't even necessarily imperative or procedural. It compiles down to a functional language, which is quite interesting. I might be mistaken on that, but anyway. Machine that powers planet-scale systems such as WhatsApp. Huh? Oh, sorry, Erlang does. I was going to say, like, does Gleam do that? WhatsApp and Ericsson. Gleam is ready for workloads of any size. Is that true? What is WhatsApp written in? It wanted to use Erlang and then it was rewritten in C++. No, it is. But why can't you just get like a straight answer? How is this relevant? How do I say I love you in programming? Yeah, so yeah, it's written in Erlang. That's crazy. Thanks to this multi-core actor-based concurrency system that can run millions of concurrent green threads, fast immutable data structures, and a concurrent garbage collector that never stops the world, your service can scale and stay lightning fast with ease. Pretty cool. I don't love garbage collection. I think that if we can find a way to not rely on it, then that's obviously better. But like ultimately, it's still pretty fast. Like we've optimized them to the point that they are really fast, and virtual machines are also really fast. So like, yes, you're not going to get C level or C++ level performance, but like the difference is really narrowing, which is pretty cool. It makes you wonder, like, at what point do we even still care about critical performance? Like, yeah, for like video games, like maybe like, I don't know, like highly important, like these things like physics simulations that need to go super fast. But for like general purpose usage, like should a general purpose programming language not use a garbage collector? Or maybe like Nim, I think Nim's quite interesting because with Nim, or maybe Odin, or maybe both, you can optionally enable a garbage collector. So that's quite interesting. C#, by the way, allows you to disable the garbage collector, but apparently it's not recommended because it's quite difficult. Anyway, let subject equals process, not new subject. Spawn a child green thread. Interesting. So it's just process.spawn with a function. Okay, so I mean, obviously that's very simple, right? Like it makes thread spawning extremely straightforward. Because like threading is always something I've done much in C++ or Rust for that matter, because I just haven't really like thought to do it yet. But like if it's this simple in a language, I may be more inclined to at least try it out, although really it's kind of like pre-optimizing. Process.send subject. Okay, so this is process.send subject as opposed to subject.send. That's interesting. I wonder if, obviously it support. Well, okay, so I wonder if it supports dot syntax for structs / classes, or if it only supports it for namespaces. Because so far this is looking like the latter. Echo, okay, go echo, process.receive subject 100, a bit like Odin, I guess. Or is it Nim? I'm really blurring the lines right now between Nim and Odin. I think Nim is echo. Yeah, maybe. Gleam JSON, resolving, Gleam test. Okay. Running apptest.main. Huh? .main. Gleam comes with compiler, build tool, formatter, editor integrations, and package manager all built in. So creating a Gleam project is just running Gleam new. Awesome. Like cargo new, right? I love a language with a proper build system and a proper package manager as well, right? Because that's what C++ still lacks. For something like, yeah, why is it not like a really good one for C++ yet? You have like VC package, but whatever. As part of the wider Beam ecosystem, okay, Gleam programs can use thousands of published packages, whether they are written in Gleam, Erlang, or Elixir. What is the Beam ecosystem? Is that for Erlang? Elixir. That's cool. This isn't the same thing. I have no idea. But yeah, Beam is cool, I guess. I mean, it's Erlang. Hold on. Does Elixir and Golang? It's not Golang. Erlang. Yeah, so Elixir also runs on the Erlang virtual machine. It is interesting when languages use like the same backend. because it means that they can share tooling support, right? Which is really cool. It's why I'm a big supporter, or like a big, supporter of the idea of like LLVM. So like both Rust and C++ both rely on the LLVM backend, which means any improvements to LLVM, whether it be from Rust programmers or C++ programmers, will impact and, it will benefit both languages. So that's really cool. And likewise, Kotlin, Java, and Scala all benefit from the same JVM backend. So yeah, no, it's really cool. It's a cool way to make a new language, right? And have it actually be usable and quite supported out the box. No null values, cool. No exceptions, awesome. Clear error messages, hell yeah. And a practical type system. Whether you're writing new code or maintaining old code, Gleam is designed to make your job as fun and stress-free as possible. That's what I like to hear. Well, there are many languages. Well, I was going to say many languages promise this. I mean, they do promise this part, but this is quite novel, I think. I mean, I suppose you could say that Rust says the same thing, but more languages that promise what Rust does is obviously a good thing as well. For some reason, I just haven't seen many of those. Unknown record field, user alias, do you mean name? Alias, the value being accessed to this type, user, it has these fields, not name. That's cool. That's extremely clear, isn't it? Multilingual, say what? Gleam makes it easy to use code written in other Beam languages, such as Erlang and Elixir. So there's a rich ecosystem of thousands of open source libraries for Gleam users to make use of. Right, because the libraries are cross-compatible, which is awesome. Oh my god, bro! Like, imagine if someone made a language that's like cross-compatible with C++. On that note, actually, well, no, because the interface matters, right? Yeah, I think for a virtual machine, it's easier, a virtual machine backend, because those, I believe, use like the same types probably and stuff like that. Whereas for LLVM, it compiles down to like C types probably under the hood. So the only way to interface between LLVM languages is through the C interface. Like as a common ground, I mean. So like you can't just like have the LLVM interface. At least I don't think you can. Not to mention, not all C++ code uses the LLVM. I kind of forgot to mention that. Like you have GCC as well, and the GNU compiler, which doesn't use LLVM to my knowledge. So if you have a GNU project, then you don't get the same benefits as you would from those Rust developers improving LLVM. But anyway, does Zig use LLVM? It does. For optimization. I don't know if it uses it for other things though, but apparently it's moving away from it. I do wonder why it's moving away from it. Like what drawbacks come with using the LLVM. Gleam can additionally compile to JavaScript. Sick. Enabling to use your code in the browser or anywhere else JavaScript can run. It also generates TypeScript definitions, so you can interact with your Gleam code confidently, even from the outside. So can I use Gleam to make a website? Because I want any excuse to make a website in a good language, I don't really want to use like React TypeScript. Like I want to just use something that's like simple. When I install Leptos, it took like an hour to install all the dependencies and then compile. Like, man. External Erlang. Okay, so at external Erlang, Elixir hpanics.new, pub function new. I see. So you declare a function and declare that it's external, like C, I guess, right? Extern C, whatever. Obviously not for C, but like same idea. Pub function register event handler. Let L equal element equal documents.query selector element.add listener L fn. So this is JavaScript, I assume. Yeah, query selector A, add event listener L function. Cool. That's pretty cool. Friendly. As a community, we want to be friendly too. I love this. People from around the world of all backgrounds, genders, and experience levels are welcome and represented equally. See your community code of conduct for more. Black Lives Matter, trans human rights. No Nazi bullshit. Wow. That is interesting to put on the home page of a programming website. But it shows that like they really do care about the community. Not care, but like they want to highlight that this is a community-driven project, which I think is really cool. Lovely people. And of course, obviously I agree with this stuff. And really, it shouldn't be controversial, but we live in a society. Look at all those people. That's cool, man. That's so cool of them to do that. So here, maybe you should read the language tour. Yeah, so show the back. This is an awesome website. I'm just going to say that straight up. I might join the Discord later, depending on how much I like the language. Last blog post was this month. Cool. Literally, today's the 20th. It was 18 days ago. I mean, I don't really read these blog posts anyway, because like usually the news is very language specific, but you don't get C++ news, at least not like as straightforward. So it's still cool. Honestly, I'm like coming from C++, literally anything that's like remotely cool, it's just like gonna be so cool in my eyes because I'm so used to like having basically fuck all from C++. Obviously we have like stuff, you know, we have like CPP con or whatnot, but oh, that's interesting. Why can I do that? Right, let's go to language tour. Enough of the overview. That was 26 minutes of overview. Right, welcome to the Gleam language tour. Let me zoom in here for the viewers at home. Cool, it auto adjusted. This tour covers all aspects of the Gleam language, and assuming you have some prior programming experience, should teach you everything you need to write real programs in Gleam. It's interactive, it's editable code, and will be compiled and evaluated as you type. Okay, so it's such as a book, which is cool, I think. Lemon in dark mode. Yeah, those are different colors. Sorry for the flash banging. Anything you print using iPrint9 or Echo will be shown in the bottom section over here. Hello, Joe. Along with any compile errors and warnings. To evaluate Gleam code, the tour compiles Gleam's JavaScript and runs it. Okay, cool. If at any point you get stuck or have a question, do not hesitate to ask in the Gleam Discord server. Lovely. We're here to help, and if you find something confusing, there's likely others will too. And we want to know about it so we can improve the tour. Nice. Let's go. So far, this is a very good introduction. Like, regardless of how the language actually is, this is like a good sign, you know? Click nice to get started, click content, jump to a specific topic, or go here to everything in one page. So there's the everything page. Cool. I am going to do the interactive tour because I'm not a unfun person. So let's go ahead. So yeah, hello world. Okay, it's instant. That's cool. I did not mean to highlight that. Okay. Import Gleam/io. Okay, so interesting. It's not standard.io. It is Gleam.io. So that's pretty cool. So what's this message? I wish I could expand this. That is my first criticism of this website. I could also just like install the compiler to be fair, but whatever. This is faster. Under the module, no module has been found with the name IO. Did you mean to import Gleam? I did. That's cool. Right, next. Hello world. So there's a tiny program that prints out the text hello Joe. We'll explain how it works shortly. Usually you'd use Gleam on the command line, but this tour is in your browser. Change it to Mike, see what happens. Yep. Modules. Gleam code is organized into units called modules. A module is a bunch of definitions of types, functions, etc. that seem to belong together. Yeah, modules are interesting. Now, again, coming from C++, I do not take modules for granted. So when I do have them, my first thought is, how can they be used to their fullest potential? And I feel like modules are really underused. Like, we talk about object-oriented programming, but do we talk about module-oriented programming? Like, I think in OCaml, you can like define functors between, or like, what's a better word to use? You can define mappings or lines, or there's an official term as well, morphisms, between modules. So like, to that sense, a module is kind of like an object. In fact, OCaml might even use modules for objects, although I might be mistaken on that. The hell? The cat just fail to enter the room. Hold on. Bit strange. But anyway, yeah, more on that in a different video, I think. The Gleam IO module contains a variety of functions for printing like print line. Yep. Hold on, is it formatted? Got 2. No. Okay. Maybe it's like printf. For hello. Go stuck here. All Gleam code is in some module or other whose name comes from the name of the file it's in. For example, Gleam IO is in a file called io.gleam and it's actually called Gleam. Right. I'm guessing Gleam is just a file extension and not related to the actual module. It's a bit confusing, but I assume that's correct. Because the directory is called the directory is called Gleam, so this would mirror the actual file path structure, which makes sense. For codes in one module to access code in another module, we import it using the import keyword, and the name used to refer to it is the last part of the module name. For example, the Gleam IO module is referred to as IO once imported. Right. Yeah, okay. The as keyword can be used to refer to a module by a different name. Yep. I don't really see the benefit in this. I guess if you want to have like an abbreviation, but like, why? Like at that point, I mean, like, if you want to avoid naming conflict, sure. But otherwise, I feel like it just complicates things. Because then if you have other people who import it differently, then reading their codes is going to be just a bit like that, tiny bit harder, more difficult. So yeah, I do wonder what are some good use cases of this. But can I also just use string? No. So it only works if I don't use if I use the as keyword, then it overrides it, so I can't use it before. Comments start with a // yeah, no surprise there, and continue to the end of the line. Comments go to the next line. Yeah, that's fine. I do prefer like this syntax, but yeah, the OCaml syntax. But obviously there's nothing wrong with this. Can I do gleam.io? No. Can I do this? No. Okay. Good to know. Next. Let me close the door down. Unqualified imports. That's weird. Normally functions from other modules are used in a qualified fashion, meaning the name used to refer to the module goes before function name with a dot between them. Right, so qualified means dot. I thought it was the other way around, but I guess I just misremembered. Okay, yeah, it does work. Is it possible? Hello? Is it possible to specify a list of functions? Sorry, like there are cats all around me right now. It's possible to specify a list of functions to import from module in an unqualified fashion, meaning the function name can be used without the module qualifier. Oh, I see. Why is it called qualifier? Why don't you just call like namespace? It might be easier. The name of the dots before it. Like if we have to put this in brackets, maybe the term just not the best term. This is qualified, this is unqualified. So what's weird to me, as I said, is that this supports both. Whereas if I did as, that wouldn't be the case. And if I did like as, I don't know, as input, or like out. Could I do out? I can. Yeah. Okay. Generally it's best to use qualified imports. This makes it clear where the function is defined, making the code easier to read. I disagree. I think if there's no ambiguity between what println is, there is no real reason to prefix it with io.println. Like yes, like it's future proofing, you could say, but you know, we're not in C++ anymore where we have includes that could just import like hundreds of things into your file. Usually if you import something, you can control what's imported. Hello. And not only that, but you can also, sorry, my chain of thought was lost. You can control what's imported, and you can also control, sorry, the compiler can inform you if you have a namespace conflict. So if I do star, does that import everything? No. Okay. I do wonder if there's like an import all option. Type checking. Gleam is a robust static type system that helps you as you write and edit code, catching mistakes and showing you where to make changes. Uncomment the line io.println 4. Oi! No, down. You can't eat that. No, down. Uncomment the line io.println 4 and see how a compile time error is reported as the println function only works with strings, not ints. Right. Special type string found int. Int is capitalized, which is cool. I'm in support of capitalized types being standard. If you need to debug print, sometimes you can use the echo keyword instead as a printed value of any type. So that is a keyword. Sure. I don't know why you really need it per se. I guess because like it means that you can use it in a library without. Like when I want to debug in C++, for instance, by printing, I actually then include print in a library that didn't previously use it, which is a hassle. Right? If I just have echo available at all times, that's quite handy. So that's a good feature. Yep. Gleam has no null, no implicit conversions, no exceptions, and always performs full type checking. If the code compiles, you can be reasonably confident it does not have any inconsistencies that may cause bugs or crashes. A lot like Rust, right? Cool. I'm just thinking, should I be taking notes of this as I go through? Because like one idea I have is to do like a language review in a blog post, but I don't know if I should do that without using the language first for like an actual project. I'll take notes. Yeah, I'll take notes. In fact, I can have this as a source note. So in that case, I'll definitely take notes, yeah. So Gleam, language tour, no particular date. Authors, I have no fucking clue. Who's like the main... Yeah, who was like the main person? Lewis Pilfoyd. Okay, I'm gonna use that name. Whoops. There we go. Published, irrelevant. Although I'll say when I accessed it, 2026. Tags, does that work by the way? Or is that an error? Yeah, it's fine. Tags, interactive tutorial, I guess. Strange, but ID is not relevant. Link. Okay, that's just boilerplate. So, what have I said so far? Nothing there, but here. Modules, it's strange to me that a language would would support import module as alias. Since why would you want the user to use a custom alias? Doesn't it make the code less consistent? Doesn't it make code bases less consistent? And in this language and in Gleam, it also importing it as a different name also means you cannot use the original name, which I think is a bit unnecessary. Unqualified imports. This claims, should I just quote it? I'm inclined to disagree, as I actually think that in modern programming languages, there is practically no reason to not just use unqualified names. Unqualified names, yeah. Unless you specifically have a namespace conflict, which can be resolved on a per basis. What's the phrase? Like, as it happens, whatever. Resolved as on a per issue basis, I guess is the way to phrase it. I don't know, whatever. Yeah, this is because unlike older languages like C, we can now control what is imported and when. Nim is a good example of a language that does just allow unqualified names by default, and I think it's pretty cool for that. Okay. Type checking. Gleam is a robust type system that helps you as you write and edit code, catching mistakes and showing you where to make changes. Uncomment the line output line 4. I just saw this, right? Okay, yeah, I just saw that. Yeah, so echo is a cool idea. I realized that the first two notes I make are negatives, but like, yeah. Type checking. Yeah, so having a specific echo keyword is pretty cool, since it means you don't have to import the IO module when you want to do simple debug printing. Yeah, I definitely have suffered from having to constantly add and remove hashtag include IOStream or print, whatever, when wanting to debug my C++ libraries. Odin or Nim, I think Odin. Odin has echo as in, that's just like a print function in general. That's really relevant. Yeah, any drawbacks to this though? Like for like formatting, like how do you do formatting? I guess you could just like echo format dot, but then like do you have to import the format library as well? But cool. I would just ensure it also comes with good formatting support, so you don't have to import some FMT module as well. Next, I clicked. Ints. Okay, Gleam's int type represents whole numbers. Right, yeah. I like when languages standardly, is that a word? Standardize the capitalization of all types, even primitive ones. Now, I don't think int is a primitive type anyway, but ones. To be fair, an int, a Gleam int is not as primitive as a C int, but I digress. There are arithmetic and comparison operators for ints, as well as the equality operator, which works on all types. What do you mean it works for? Or hear noises. What do you mean for any type? Does that mean it's like a default implementation of it? We're running on the Erlang virtual machine, ints have no maximum and minimum size. We're running on JavaScript, runtime ints are represented using JavaScript 64-bit floating point numbers. Makes sense, to be fair. The Gleam instant library module function contains functions working with ints. Oh, that's weird. Is there an example? Yeah, int.max, int.clamp. Okay, I guess. But like, notice how, I mean, to be fair, like you could just like make it like a static function, like, but like, notice how because int is capitalized, we can use int as a module name, which is quite important actually for language modules. I didn't think about that. For like C++, it matters less because you can't have imports anyway yet, but for other languages, it does matter. Cool. Yeah, I mean that's fine. I think. Like this is obviously an implementation detail, but if you're using this language, you probably don't care about the performance of these integers anyway. Floats. Gleam's float type represents the numbers that are not integers, also capitalized, but imports Gleam float with lowercase. Gleam's numerical operators are not overloaded, so there are dedicated operators for working with the floats. Hold on. Why are there floats in the first place? Because for JavaScript, it just uses floating point numbers, so that's already like, doesn't matter. And then, I mean, for the Erlang backend is different, but like when do you need floats versus numbers? You know, like in a language where you don't care about the size of your integers and like all that kind of stuff, why does it actually matter to have different floats? Like treat floats differently from like to just have numbers. I mean, you know. In a language that doesn't care about the size of integers, for JavaScript, Gleam ints just compile to doubles, well, 64-bit floating floats. Why treat ints and floats separately and not just have a unified number type? Gleam's numerical operators are not overloaded. If so, there are dedicated operators for working with the floats. I think this is a mistake unless your language specifically has duck typing, because like if your left side is a float and your right side is a float, why does it matter if you use plus? Like we know it's floats anyway, you know? So this is already routed the wrong way. And it's reminiscent of like Haskell, although Haskell overloads the plus operator anyway, so yeah, that's just weird. Floats are represented as 64-bit floating point numbers, okay, as well. For both Erlang and JavaScript, the floating point behavior is native to their respective runtimes, so their expected behavior will be slightly different on two runtimes. Yeah, I mean, a question I did also have was like, how will it compiling to both JavaScript and Erlang VM, like how will that affect? There you go. Yes, open. But the cats are dumb. Cat flap. Sorry. Yeah, sorry. So because it compiles to two targets that are quite different, like I was wondering how it would affect the language itself and like how it works. And I guess it just accepts it. Under the JavaScript runtime, exceeding the maximum was infinity. Should you try to divide to infinity, you'll get nan. When running on the beam, you get an error. So there's no nano infinity float value in the Erlang runtime. That's quite significant. So really, when you create a project, you probably want to be targeting just one of the one target, as opposed to generically all of them, unless there's like a way you can handle these. Like, what if you want infinity, you know? I guess you just can't have it. Go for the more strict option. Division by 0 will not overflow, but instead be defined to 0. That's problematic. Then again, is it... The Gleam float language library contains functions, yeah, okay. So we got these like dot, dot, dot. So more than dot, less than equals dot. I'm not a huge fan of that. But equality works for any type. Like, why does equality work for any type, but other things don't? That is very strange to me. Like, they've said it does, but they haven't explained why. Why does equality work for every type? Languages notoriously typically reserve special behavior. Well, whatever. In general, I would like if language introductions not only stated the way... If language introductions gave reasoning for everything that they state is a... My cats are strange. For everything they say is part of the language. Yeah, over there. Next, underscores can be added to numbers for clarity. Cool feature. Int can be written in binary or hexadecimal. Yep, make sure to use O for octal as opposed to just this, like you got in C and by extension C++. Horrific. Floats can be written in scientific notation. Very cool. And it supports decimals too. Does it support decimals for like... It does. Cool. Next. Equality. Gleam has the equals and not equals. The operators can be used with values of any type, but both sides of the operator must have the same type. Of course, equality is checked structurally, meaning the two values are equal if they have the same structure, rather than if they are at the same memory location. Okay, I would expect that to be the case. Is there a structural equality? Is there a identity equality then? Although, I mean, I never really understood that. Like, yeah, you could have an identity operator like that, but you can also just do, you know, like the address of foo equals the address of bar. And like, that's also perfectly valid. Or like, if you wanted to simplify it, you could do like this, address equals, or address equals equals. I'm aware that like the bits operator exists, but let's assume that it doesn't, because those really shouldn't have reserved syntax like that. They're not common enough these days. Uh, 0.1 times 10. Oh, it's not equal to 1.5. Okay, yeah. Next. In Gleam, strings are written as text surrounded by double quotes, Unicode, Konnichiwa Gleam, and can span multiple lines and contain Unicode characters. I forgot what this is called. I would like a name for these things, by the way. So like when you read it, you can just know what to say. This operator can be used to concatenate strings. Okay, I've seen this in some language. I can't remember which one now, actually. It wasn't OCaml. I can't remember which one uses it, but Haskell uses ++, which I personally prefer, but I suppose you can use this for concatenation. Maybe it was OCaml, actually. Several escape sequences are supported, double quote, backslash. Unicode code points, pretty cool. The Gleam string library contains functions for commit strings, as we kind of saw, right? Reverse, append. Why do you need string.append? That seems redundant to me. Multi-line string. Okay, pretty expected. A bool is either true or false. It capitalizes true and false. The or, and not operators can be used to manipulate bools. That sucks. I really would like a language to deviate from that. The or and operators are short-circuiting, meaning that if the left-hand side of the operator is true, then it does that. Yep, lazy evaluation, very cool. The clean bool, can you call it that? I guess short-circuiting is a term to use. The Gleam, blah, 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 for working with bools. So bool.toString true. So notice you can't do true.toString, which is a shame. True as a string in double quotes. If I were to do io.println, would it still work? Import Gleam /io. Let's do io.println. Yep, and that removes the quotes. Cool. Next. A value can be assigned to a variable using lets. What? Variable names can be used by letter let bindings, but the values they reference are immutable. So the values themselves are not changed or mutated in any way. Can you get them mutable? In Gleam, variable and function names are written in snake case. Okay. That's not snake case. Exactly. Let x equal original. Print x. Let y equal x. Okay. So it seems like it uses automatic type deduction. Can you be explicit with the typing? Is string even a type? It is a type. Okay, good to know that works. Semicolons are not supported. Good to know. Mutable. Are they mutable mutations? No. Okay. Discard patterns. If a variable is assigned but not used, then Gleam will emit a warning. If a variable is intended to not be used, the name can be prefixed with an underscore. Try changing the variable name to score to see the warning. Yeah, I don't understand why you would even do this, honestly. In what situations do you have unused variables? Obviously, if you're building the application at the time, then that's fine. But if you are having a finished program, why would you just have unused names like these? Why don't you just do this? Let underscore instead. Also, can I use multiple? I can, that's good. Is there shadowing? There is shadowing, okay. What I would do is just remove that. And if I really want the name, I'd do this. But then what is the purpose of this? I'll just I don't know, this is a more realistic example. But then here I don't need it, do I? Yeah, it's strange. But I mean, obviously it's a cool feature to have. I just don't see it as particularly important. I'd rather have underscores be reserved for something else, like public and private or something. Or really, I just prefer not to have this at all. I think it's just an eyesore. Better to have actual things like ignore or something like that. That's my opinion. Let me type, please. Discard patterns. I don't see the point in prefixing variables with variable names with boom to silence unused variable warnings. Literally, why would you want to have named unused variables in your code that you can't just describe with a comment or self-document somehow? And even then, I'd prefer to just use some kind of keyword to indicate that a variable is unused, unused. Type annotations. There we go. Saw that already. If I remove it, I get a warning. I mean, it's good for like demonstrations, I guess. But that's a really niche use case. And again, once again, I prefer an unused keyword. Type annotations would be useful for documentation purposes, but they do not change how Gleam type text to code beyond ensuring that it's correct. Right, so I can't do this. That is cool, I think. Typically, Gleam code will not type. Yeah, okay. Try changing a type annotation to something incorrect to compile error. Yeah, like Haskell, I guess. Like Haskell will do type deduction, but if you do it explicit, then it will still do type deduction, but it may narrow the type or broaden the type, whatever. Type imports. Other modules may also define types that we wish to refer to. In this case, you need to import them, so you prefix them. And they use Pascal case. I mean, do they? I assume so. See what I mean? Like, why do we, like, this being qualified is just weird. Types can also be imported in an unqualified way, but I send them in the import statement. Yeah, unlike functions, Gleam types are commonly imported in an unqualified way, which makes sense, because, like, why would you want to do string tree dot string tree, like, and the same goes for functions, really, but whatever. I still wonder why it does this. Like, why not just have string tree dot new or colon new? Like, this is just really jarring to me, having like these conflicting, like you have the struct name here, but then you have this, which is a module name dot new. So like the module is the struct for the struct's functions. But like, why not just have like this? This is my issue with having modules, right? Unless you're going to specifically use modules to have like functors and morphisms between them, don't use them. Like in Java, a module is just a class because a class already gives you encapsulation. Like, that's fine. I prefer to have that style of object-oriented programming than to have modules act as classes and then do weird stuff like this, which is just stupid. Like, I can just omit this, right? And that, okay, it's never used, whatever. Let's say I get rid of that warning. Like, now what? Like, it just reads really weird. So I'm really not a fan of that. Yeah, I'm not a fan of code like this. Does it have highlighting? It doesn't. That's fine. Because why are we importing? Because why are we using the module containing the class, the struct, to act like a wrapper for the struct's methods? I think it is much more logical to just use structs as the natural tool of encapsulation. Now, there is an argument for like just treating structs as pure data and then having functions around the structs instead of inside them. So like the structs don't own the functions, but then you can't do things like have trait systems and like polymorphism. I mean, can you? Not really. Like how can you do like overloading? Like, are you going to overload everything? Like to string? Do I have to overload that? Or like, does it have to be namespace? It's just, yeah, I just don't understand the appeal. I don't. Type aliases. These are cool. Hold on. This has tripped me up as well. Why do I need to specify type there? Like, why do I need to put type string tree? Why can't I just import it? It cannot be imported as a value. That's weird. I don't know why that's necessary. I also don't get why I need to prefix my import, prefix the struct import with type. Another thing that is not given justification in the tutorial. Type aliases. Type alias can be used to refer to a type by a different name. Given a type an alias doesn't make a new type, it is still the same type. A type's name always starts with a capital letter, contrasting to the variables and functions, which start with a lowercase letter. And the Pascal case, but it doesn't seem to mention that. When the public keyword is used to type, the type alias is public, it can be referred to by other modules. Yeah, no surprise there. Type aliases, same for functions, but I guess functions coming later. Type aliases should be used rarely. Editing a type makes it less clear what it is and does not provide the type safety benefit, that using a custom type would give. Oh, then why support it? Literally, why support it? I don't understand. This... Although there is reasoning given for why you should not use type aliases, there isn't justification for why they are therefore in the language in the first place. And I'm also glad to disagree. I think it's fine to use aliases if you want like something particular, like student ID being an int is surely fine. This is just a bad example. Like having a number as an alias is just a bad example. But like if it's student ID, like why is it bad to give that a thing? Like C++ wishes it could do that, you know? Like literally, like I think Bjarne has got to say that like he wishes that, or like an aim for C++ is to support user-defined types that just look like normal types, such that I could have a student ID like this and then just add it to another one, and like that would just work, you know? Whereas, I mean, obviously those are things, but like this, I mean. Whereas in C++, you would have to overload the plus operator for your type, and it's just really cumbersome. I'm not even inclined to agree that type aliases should be avoided. The tutorial, the guide uses int equals number, or number equals int rather, as an example. But what about something more logical like student ID equals int? Next. Blocks are one or more expressions grouped together with curly braces. Okay, each expression is... Sorry, expressions grouped together. So these are all expressions. So it is expression-based language. Each expression is evaluated in order, and the value of the last expression is returned. Like Rust. Yeah, I don't like this. It just reads weird. I said it before, I'll say it again. It just looks weird. Like, why can we just return or have like a result equals, like just something, you know, like just throwing degrees at the end is just so weird. Like I get for like a functional language, by the way, like it's completely fine because like the body of a function is just one expression. That's totally fine. But for this, we have like imperative, and then we're just throwing in an expression at the end, and like that's just really jarring because it's like, well, are we doing functional or not? You know, like you can say that this is an expression. Like maybe it is under the hood, but like when I'm reading it, it reads like a command. Let degrees equal 64 is not like, it doesn't read like an expression. So to say that like this is an expression, it's just wrong. Like it's just not correct. And therefore this just looks weird. And this bothers me in a multitude of languages, including Rust. But it's better in other languages like Haskell, where they don't promise to make it look imperative anyway. Obviously you like do notation, but anyway, whatever. I still really dislike throwing an expression at the end of a block. Yep, at the end of a block, to have it be the return value. I think it reads really weirdly, especially considering these languages otherwise read like imperative code. Even if they claim that the imperative looking code is actually made up of pure expressions, the fact that it still reads like imperative code is enough reason to is enough reason for having the rogue expression at the end of a block look weird. Now, I do like the idea. I do like the idea of reserving return or a similar keyword or some other keyword for early returns only in the case of errors, but I definitely do not prefer this. Yeah, Rust is one such language that does this. That also falls for this trap. Any variables assigned with a block can only be used within the block. Makes sense. Try and commenting the echo degrees to see the compiler error from trying to use user variable. Okay, the name degrees is not in scope here. Okay, so it doesn't acknowledge that it exists in the code, but it does tell you that's not in scope. Blocks can also be used to change the order evaluation of binary operators expressions. I think that's a typo. Should say binary operator expressions. Not a nitpick here, but that is okay. This is very good. I said before towards the start of this video. It's been an hour already. I said at the start of this video that Gleam is a language that apparently tries to keep things small. So if there are overlapping features, it will try to minimize that overlap. And this is cool. Obviously, it doesn't read like you would kind of expect math to read. Like you must never use curly braces for this in maths, but yeah, this is cool. The way that it utilizes this instead of parentheses, and then it means that parentheses can be reserved for function arguments, for tuples, for function calls. So that's cool. I haven't seen this before, so that is quite a cool feature. The use of boom boom instead of boom boom for enclosing expressions, sub expressions, for the sake of operator precedence and readability is really cool, despite being anti-math notation. Despite not matching math notation. It then frees up the boom boom for to be used unambiguously for stuff like function calls and parameters. And that's kind of all it's used for, right? I can't really think of anything else that it's been used for in my experience. So that's very cool. First, like, proper wow feature. Times, binds mortality, then plus, so the expression 1 plus 2 times 3, 5, 6, 7. I am in support as well of languages that don't support. Yeah, for the record, I am in support of languages that don't support operator precedence in the first place. In fact, Clang Tidy will even tell you to use parentheses regardless, just for readability's sake. It doesn't help that not everyone is familiar with PEMDAS somehow, which really should be PEMDAS, but I agree to disagree. This is asymmetric grouping with parentheses in some other languages. Similar, it's literally the exact same, except this is a scope. Okay, I will say, This is only possible because you can throw an expression at the end of the thing, to be fair. In fact, in C++, how does it work with scope? Let me do this, include IOStream. Let's say I have in my main function, let's say I have int x equals then a scope like this. And I'll say, but first of all, if I just put int y equals 5, that should return 5, I think, as well. So if I then do standard cout x, it should output 5. Could be wrong. Never mind. Express the primary expression before int. Okay. Ooh, yeah. Maybe you can't actually define nested variables. Oh yeah, this is so wrong. Never mind. Okay, never mind. Yeah, no, never mind. It's different in C++. Yeah, so to his credit, this is only possible because you can do this. But then I would just rather advocate for, so you can do, okay, hold on. To Gleam's credit, this is only possible, this boom boom syntax is only possible because of being able to do implicit expression returns. But I would rather that this was reserved for one line, for one-liners. Yeah. Cool. Lists. Lists are ordered collections of values, so we don't use arrays. List is generic type, having a type parameter for the type of values it contains. Okay. A list of ints is type list int. Okay, so parentheses are also used for types, like templates, kind of, or generics, however you want to. Well, I see this language that doesn't have a fully fledged template system, so generics then. Which is cool. As opposed to some other syntax. And list of strings has a type list string. Lists are immutable, single linked lists. So I guess there are arrays then. Well, no, because this is a list. Okay, so by default uses lists. Meaning they're very efficient to add or remove elements from the front of the list. Yeah, that's kind of it though. Counting the length of a list or getting elements from other positions in the list is expensive and rarely done. It is rare to write algorithms that index into sequences in Gleam. But when they're written when they're written, a list is not the right choice of data structure. Yeah, use an array. I mean, like Haskell, right? But like, obviously I see like why you would do this, but I just don't like it, dude. I wonder if array syntax happens to be Angular bases. Fuck, that would have been awesome. What's wrong here? It's just like, yeah, prepending, okay. Type error. Yeah, okay, fine. Constants. Const. As well as let assignments in Gleam also has constants, which are defined at the top of a module. Constants must be literal values, functions. What? Constants must be literal values. Functions cannot be used in their definitions. Okay, that's a run-on sentence. Look, if I see bad grammar, I'm gonna point it out because like it does actually trip me up, and it sucks too because I get so used to reading things with bad grammar that when I read things with good grammar, it actually impedes my ability to understand the good grammar because my brain has auto-corrected it into bad grammar. Like it's actually ridiculous. or like it thinks it's bad grammar, autocorrects it to what would be good, then realize, oh no, it was good, so now I've just changed the meaning to something. Like it's crazy. Like I'm becoming dyslexic from reading too much bad grammar. It's actually insane. So if you can't use functions, I assume that means you don't have comp time functions, which is not ideal. Constants may be useful for values. Well, it's actually not ideal at all. Constants may be useful for values that are used at your program. What else? Permits them to be named and to ensure there are no differences in the definition between each use. I guess compile time isn't really a concern then. Using a constant may be more efficient than creating... Okay, never mind. We can the same value in multiple functions, though the exact performance characteristics will depend on the runtime. Yeah. I do forget that this is language that isn't like systems anyway, so... Functions. The FN keyword is used to define new functions, like Rust. Similar to blocks, each expression in the function body is evaluated in order. I would expect them to be exactly like blocks of anything. And the value of the last expression is returned from the function. Gleam is an expression-based language. Now it tells me. So there's no return operator at all. But there are ways to conditionally return from a function, which will be introduced in the lecture section. Okay. The double and multiple functions are defined without the pub, so they are private. Yep. To lightweight assignments. Oh, my head. Type annotations are optional for function arguments and return values. First of all, I like the out of ordering here, that you can define main first. I don't like how this though. It says they're optional, but that means like if I just neglect to include my type annotations, that compiles. Yeah, so I guess here it would use duck typing. Like if I do this, then it would want me to use a float here and here. I have to remove this too. Yeah, that's kind of fucked. I'm not a fan of that. But okay. Did I read everything? Yeah. High order functions. Nice. Just fn into int. Good syntax. In Gleam, functions are values. They can be assigned to variables, passed to other functions. And anything else you can do with values. Here, the function add1 is being passed as an argument to the twice function. Notice the fn keyword is used. Yeah, I did try to think of a way to like not need the fn keyword, but I did realize that it makes parsing that much harder, so... maybe you should just include it for simplicity's sake. Even though like it does add a... Like it acts like functions are vastly different from variables. Call a function with another function. Yep, cool. In like currying or I don't know. Otherwise pretty standard. Anonymous functions, you got lambdas, which is just this. Yep, this is pretty much what I wanted them to look like. So I think that's perfect. Because it's consistent with the type signature and with the idea that you use blocks as functions anyway, but just like argumentless functions. So that's pretty cool. Anonymous functions can be used interchangeably with name functions. Anonymous functions can reference variables that were in scope when they were defined, making them closures. Yep. So how do I call a anonymous function? Like, can I echo fn? Well, first of all, can I echo it in general? Like, let's say I can 5. I can. I don't know why it's like that though. And then can I invoke it? I can. So yeah, that's pretty cool. Not much to say there really. I assume I can also have an explicit return type. I can. I think there's a language where you can't do that for some reason. Okay. Function captures. Special syntax for functions that take one argument and immediately call another function with an argument. The function captures syntax. So some function can be written as some function blank. I don't like how they're called function captures, because capturing makes you think of something else. If you know, you know, I guess. But like, okay, with the number of the other arguments passed with the underscore, blah, 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 blah. Sure. Yeah, that's pretty cool. I give it a different name, and I would second guess adding that, but it is interesting. There is syntactic sugar for functions that call other functions, such that these are identical. So we're saying a function add and this are the same, which is pretty cool. Add one v1, add one v2. I'm trying to think. Obviously, it's like a form of partial application. In fact, this might just be the key to having partial application in a non-functional syntax. Because if this was like Haskell, you would do it like this, and then this would like implicitly be a thing. But the issue was that, first of all, it doesn't translate well to parentheses calling syntax, but also like it's kind of like you don't know what comes after this, so it's kind of ambiguous. If you were forced to use an underscore, it would already be better, more clear. And then if you then also enables you to use it with list arguments. So this is actually quite good. This is really good. Now, granted, it is just syntactic sugar for this, but it is quite good syntactic sugar, and having that native support is quite cool. Honestly, this is the best approach to partial application in non-functional syntax that I have seen so far. And even functional languages would benefit from explicitly requiring an underscore for partial application or querying IMO. Yeah, that's cool. I'm gonna get some water real quick because I haven't really drunk anything today. I've really eaten today, so. We love drinkable tap water. Right. Generic functions. Up until now, each function has accepted precisely one type. The twice function in the previous only returns functions that would take and return ints. This is overly restrictive. It should be possible to use this function with any type, so long as the function and the initial values are compatible. To enable this, Gleam supports generics, also known as parametric polymorphism. This works by using a type variable instead of specifying a concrete type. Right. And we use a lowercase name. The name value refers to the same type multiple times. I see. So value is the type here. Yeah, I mean, I think it's like Rust, right? If I'm not mistaken. Like you just do T, and then it automatically makes T a type. Type variables are like a type deduction. Type variables are not like any type. They get replaced with a specific type each time the function is called. Try uncommenting twice, 10 exclaim to see the compiler error from trying to use a type variable as an int and a string at the same time. What twice do? Twice takes this, then my function. Okay. So in this regard, it's a bit like Zig, where Zig would just put here any type, I think, and then you would do like type of argument, like that, which is obviously more verbose, but it's kind of the same concept. Although in this case, you got the convenience of just being able to do this. I could do T, of course. That should work. Can I do capitals? No, it has to be lowercase. Interesting. Makes sense though, I guess. Ooh, so what does Rust do? No, Rust requires that you've put them here, I think, right? At least, which makes sense. Pipelines is common to want to call a series of functions, passing the result of one to the other, right? So this is a godsend feature. Rust, C++, please, for the love of Christ, add this. Piping is awesome. It's common to want to call a series of functions, passing the result of one to the next. Yeah. So like rather than like having to rely on, you know, function, oh no, like monad patterns manually in your functions. Ooh, that's crusting. That's not good. It's way cooler, way more flexible if you just have piping that does it for you. With regular function called syntax, it's going to be a little difficult to read as you have to read the code from the inside out. Yeah, so it's like you're printing the line of start, drop, and hello Mike. But honestly, it's easy to read things backwards. I have hello Mike, I drop the end, I drop the start, and then I print line. Like, it's just such a nice way to read it. Like, this is not nice to read. And it's why I almost always will break every single one of these nested function calls into its own line and its own variable. Piping just completely makes that unnecessary, and it's awesome. The only weird thing is obviously this, like the first argument becomes implicit, which is a bit weird, but it works. Personally, I'd probably just add this just to be consistent and treat it as if like the arguments are getting reduced, but I think that's cool either way. The pipe operator takes the result of the function on its left. Yep. It will first check to see if that value can be used as a first argument to the call. If not, it falls back to calling the result of the right-hand side as a function. Right. So if this happens to return a function, then it will apply to the function, which is, yeah, makes sense. Gleam code is typically written with the subject of the code function, of the function as the first argument to make it easier to pipe. If you wish to pipe to a different position, then a function capture can be used to insert the argument to the desired position. Ah. Okay. Okay. Now, I will say, conventionally, that makes sense anyway, having a subject. In fact, it's almost an idea to enforce a rule in your language where the first argument has to be the subject, or like has like a special syntax to like separate it apart from the others. If you need to debug printer value in the middle of a pipeline, you can use echo to do it. Yo. That's awesome. That's huge. That makes debugging so much easier for like functional syntax style stuff. Huge, man, huge. So what I would do here is unify the syntax and just do this. I know it's verbose, but it's clear. We're setting it here, then we're setting the result there, then we're setting the result there, you know? And then if you do this, then this becomes natural as opposed to like a special case. And you could potentially do other things with it too. Like let's say I wanted to take my thing and then do this, like foo. Like I could do that in theory, right? But yeah, I will of course write notes about this one. Pipelines. I love piping. Pause. Resume. I love piping. And I really hope that they get added, well, that the operator gets added to Rust and C++ in the near future, because I need this in every language I use. It makes things so much easier to use. Goddamn. Like, it's crazy. Like, the fact that I haven't yet used a language that supports piping is just, it's tragic. It's also tragic. Maybe Nim does actually. Hold on. Does Nim? Oh, okay, thank you. Does Nim have piping? Probably not then. Yeah, so yeah, out of piping. Nim. So I do like how it uses the function capture syntax though. Because like, what if I want to apply it to an actual anonymous function? Wait, let me think. This would return a function call that takes an argument. No, never mind, it works. No, this works perfectly. Never mind. Gleam takes it a step further by integrating it seamlessly. Well, maybe not. Integrating it with its function capture syntax. Yeah. Like so. I can't control Z any further. Can I control Y? Okay, never mind then. But yeah, like this is just so good, bro. It's so good. So I need to change my font on thingy here. Little side note. Let me do it right now because it's actually something I was thinking about in bed this morning. Yeah, open my file, please. Go to this thingy. Members, references, code.css, no code. I think font family, JetBrains, mono, nerd font. That might not be correct. Let me actually just refresh, please. Enable. Yeah, let me inspect. Font family, JetBrains mono. But it does work. Hell yeah. Awesome. Oh, dude, look at that syntax. Ah! I love JetBrains. Such a good font. Right. Okay, that should apply now. I don't know when it will apply, but it works for now anyway, because I just did it manually. Let's see if it persists later. Ooh, in the code editor it doesn't persist because the thing changed. Let me reload. How do I reload this application? No? Okay, just open it again then. What the, what? It didn't work. Why didn't it work? Maybe it's like overridden, potentially. It's in pre, but it's in a code block too, right? Search for a font. It's a bit slow. Actually, it's very slow. I am almost a bit concerned. See if OBS lags because of it. Font family, font monospace. Yeah, here. Yeah, okay, yes, it's being overridden. Where is this? App CSS. Can I override these variables elsewhere? Okay, Obsidian is really lagging. Okay, we're back. A bit of a detour, I apologize. Maybe through here somewhere. Style settings. Colors, editor, miscellaneous. Is there a search bar? No. Editor. Font. Font family. Nice. Code box. JetBrains mono. And also inline. See if that works. It does work. Okay, that'll do for now. Anyway, yeah, it's like this. In fact, I need to use the other example. However, I wish the syntax was more unified and instead required this capture syntax regardless. This simplifies things and means you could also potentially do stuff like this. Hello string oh, never. Let's just assume that we have an entity function. Entity does nothing. It returns the input. Yeah, so like this. It gives you this appending world, right? Obviously not the most useful example, but it is an example nonetheless, right? Simplify things is less of an eyesore. I'm using supposed like this. Therefore, pipe syntax desugars to a series of anonymous function calls. Yeah. Cool. Oh. I also love how you can boom boom echo to debug, to print debug midway through a pipe sequence. This is essential in all caps. Okay, very cool. That's awesome. Obviously with a few tweaks, but still awesome. Labeled arguments. When labeled, bro, this should be like the requirement for everything. Like I'm not even joking. You should. I personally believe you should be forced to use labeled arguments no matter what. When functions take several arguments, it can be difficult to remember what the arguments are and what order they are expected in. Okay, now there is a like, let's say I add A and B, right? Do I need to name those? Probably not. Yeah, probably not. When a function takes several arguments, it can be difficult to remember what the arguments are and what order they are expected in. To help with this, Gleam supports labeled arguments, where function arguments are given an external label in addition to their internal name. These labels are written before the argument name of the function definition. Now, you can make them optional, obviously, but I just feel like by enforcing it, you ensure that code is readable without needing like an IDE to fill in the blanks, right? Like I know it's verbose, but like when you write a function, like for example, Rust already requires that you label the members of a struct by name when you assign values to them, when you create a struct. C doesn't, but Rust does, and yet Rust doesn't have named function parameter arguments, so that's weird. But yeah, I think it's a small inconvenience for how readable it makes your code. To help with this, Gleam supports labeled arguments, where function arguments are given an external label in addition to their internal name. These labels are written before the argument name of the function definition. When labeled arguments are used, the order of the arguments does not matter, but all unlabeled arguments must come before labeled arguments. Okay. Hold on. Oh shit, hold on. Oh. Wait, what? Hold on. This is way different. These are separate names, so they have two names. Why? There's no performance cost using labeled arguments. Well, obviously, I assume it'd be a runtime thing. Labels are optional when calling a function. It is up to the programmer to decide what's clear in their code. Sure. Not really, but why? Okay, this just seems unnecessary to me. First of all, better to have a unified name because like that's what you are labeling it as. I don't understand. Like you wouldn't call it add anyway. Like either this idea isn't good, or their example just really sucks. Or both, because like you wouldn't call a thing add unless you want to do some like weird naming scheme, which I would argue you should be using anyway. This is a really weird way of supporting labeled arguments. Why does there need to be a second name that is different, or at least separate from the internal name, or from the parameter name. Yeah. I would just use the same name for both, and potentially you could use the underscore prefix syntax to denote fields which do not need to be named. For example, add A and B. Right? That is an interesting idea, but this I'm not a fan of. God help me. Like, is this not problematic? Discount, unit price. Like, why is it like, literally whenever you have a different name, the question is just going to be straight up, why are you using this name? Like, it doesn't make sense. Like, yeah, that's dodgy. I don't like that. This is cool, I guess. Label short and discount. This is cool though. Gleam. It allows you to let quantity equal 5, let unit price equals 3, let discount equal 1. I don't know. 20 actually. It allows you to, but like they're optional anyway, so it's just really weird. But it allows you to pass variables to pass local variables as function arguments when both share the same name, but with an explicit syntax rather than implicitly, like Rust does with structs, unlike what Rust does with structs. Okay. And it can also be used for records. I don't see a record yet, but okay. Doc comments. Gleam has triple and quadruple comments, which are used for attaching documentation to code. This is for types of functions. This is for modules. Okay, sure. Deprecations, functions, and other definitions can be marked as deprecated using the deprecated attribute. So there are attributes. There's also the import attribute, right? No, external attribute, or extern even, for like external import functions, whatever. If a deprecated function is referenced, the compiler will emit a warning, letting the programmer know they ought to update their code. And you have nil. I guess. Cool. Yeah. Pretty standard. Case expressions. Okay, I don't know why this is left so late, because this is like quite an important feature. Well, like I guess we should cover the basics so far. The case expression is the most common kind of flow control. Control flow. In Gleam code, it is similar to switch in some of the languages, but more powerful than most. So it's like match. It allows the program to say, if the data has a shape, then run this code, a process called pattern matching. This is like really a side thing, but like I don't like it when new languages talk about these things as if like they coined the term. Like at least link to like the Wikipedia article or something. This is a nitpick I will have to note. Case expressions. I don't like it when language guides introduce a term, a programming term, as if they coined it. It would be good to at the very least link to the Wikipedia article or something. This is not just for the sake of paying homage, but also to let the user know that this is indeed a recurring feature in other languages. Gleam performs isosceles checking to ensure that the patterns in the case expression cover all possible values. With this, you can have confidence that your logic is up to date for the design of the data you are working with. Try commenting out patterns or adding new ones and see what problems SecondPilot reports. So what's like the do nothing? Well, I mean, I guess in this case you can't. Yeah. Okay, results. Is nil an option? Ooh. To do. Never mind. Interesting. So to do is the same as this. Okay. Cool. Random 5. Does it do a different number each time? It does. Can I get... There we go. Yep, nothing special there, I don't think. Patterns and case expressions are also can also assign variables. Oh, like here, sorry. Yeah, okay, it's like some of this. Yep, okay. String patterns or pattern matching on strings. The bubble operator can be used to match on strings with a specific prefix. That's interesting. Okay. Not sure if I'm a fan of that. I'd prefer you just use like a range or something. The pattern hello name matches any string that starts with hello, but whatever. List patterns. List and the values they contain can be pattern matched in on in case expressions, much like Haskell. In fact, the syntax looks... No, it uses dot instead of thingy. So this matches a list with one element. Cool. The list append pattern can be used to match the rest of the list. Okay. Recursion. Oh, there's no loops. Oh, kill me, bro. It's over. It's over. I'm sorry, Gleam. It's over. What the hell? How'd you know of loops, bro? Iteration is done through recursion. Sorry, and there are no mutable variables either, are there? A recursive function... Isn't this just like a worse Haskell? But it uses the Erlang backend, I guess. Top-level functions calling themselves with different arguments. A recursive function needs to have at least one base case and at least one recursive case. A base case returns a value without calling the function again. A recursive case calls the function again. The Gleam SG standard has functions for various common looping patterns, some of which will be introduced in future lessons. Recursion can seem daunting or unclear at first if you're more familiar with languages that have special linking features, but stick with it. With time, it will become just as familiar and comfortable as any other way of iterating. That's so false. Chat, that is such a lie. Recursion is not natural. It's... please don't... I don't like recursion, bro. Anyway, step towards 0. What? Why would you not just do x minus 1? I don't follow. Step towards... okay, you have this. Plus 1 if it's false. So 1. Okay. By the way, this is a look at... okay. This is a look at the if statements. Notice how instead of using an if statement here, it uses a match on a Boolean, which I think is pretty cool. It just unifies the syntax, which I think is quite cool. Yeah, I am a fan of that. However controversial it may seem. What the hell? I mean, if you try this out normally, you do if more equal to 0, then x minus 1, else 1. So like it is more, it is like one less line of code, just saying. And also, I mean, obviously you could like do this instead. Where you have like a one-liner, but aside from that, it's pretty cool. Also, the nesting here kind of sucks. Because then if I wanted to have multiple lines, it would have to be like this, wouldn't it? And that would not be so good. In fact, it'd be horrifically verbose. Yeah, but still, I like the idea. I just don't... I'm just kind of wary of this. If you have like multiple lines or something, that is not ideal. But anyway, it works, doesn't it? It works. Can also do this, I guess, right? Nothing's stopping you from doing that. And yeah. Why can I? Okay, the Control Z does not go far. Looks like it can be set. So I'll take note of that. Recursion. I think it's really cool how Gleam doesn't have if statements and instead relies on pattern matching. Plus, if you want to have a case with just like nothing, you just do this. And that's perfectly fine. What? Never mind, you get a warning. Well, shit. Seriously? Okay, well that's kind of problematic. What I was expecting was that this wouldn't give you a warning. And then instead, because like obviously you won't have the way to just do like if something and like just do that and like otherwise do nothing, right? So this is kind of funky, but okay. Yeah. Weirdly, the compiler warns you if you try to put nothing in the false branch. So I wonder how exactly you're meant to do if without else. It also this is just generally way more verbose. Honestly, I think a better way to do this would just be to have, for Boolean specifically, have some syntactic sugar. So instead, does this work, by the way? No. But like some languages will support this. And then if you had that, you could do that instead. Or just have case equals 0, then equals 1. Yeah. Yeah, like, yeah, if. And like likewise, like for other two-state things, like let's say if I have x, right? If it's some x, do this, otherwise do nothing, right? Like I think there's something there. Let me actually write down my thoughts properly so that I can communicate them a bit better. Especially if you want multi-line code within each branch. I would certainly consider some kind of syntactic sugar for this. Maybe something like case x equals 0, then x minus 1, else x plus 1. Wait, sorry, it's called case. I just realized. Why the hell is it called case? Ooh, this actually works quite well then. Hold on, this was really well. This works particularly well in this instance because the keyword is case rather than switch or match, which reads as we are considering this case and matching on its value. Hence, this syntactic sugar should feel natural. Yeah. So it means that like here, like I was saying, okay, so for the case of x more than or equal to 0, if it is true, do this. If it is false, do this, right? This says, for the case of x more than 0, just we assume, okay, if it's true, do this, else do this. And what else does is equivalent to this, which I think is really cool. And it would, obviously you could only have it work for Booleans, but you could also consider making it work for other types too. Like have a case sum x, else do this. And then, yeah, and this could even be extended to other language features like Gleam case sum x, then x plus 1, else echo x, else echo error. Right? And then this, yeah, and like this seamlessly unifies Rust's match, if, if let into one feature. And then it also supports just this as well. So then by default this does nothing, right? Some other cases that could be considered. Yeah. So say you have some x, echo x, else do nothing. I could have case none. I mean, obviously that doesn't work, right? Some x. Okay, so to have let else instead. Could do this, right? Like it's hardly much, is it? How's it work in, I think in Rust for else, it just works, right? Like if do this, else do this. Let me just double check. How does let else work in Rust? Yeah. So it's like instead of having the question mark operator, you just do it, right? So like, yeah, I mean, like, yeah, like, this is fine. Yeah, so let else. I mean, it's not really let else, obviously, because it's a case, right? But like, it just simplifies things. Because else covers any other case. Yeah. It's kind of perfect. Likewise, if I have case, what's results? Okay, and then error, right? So x, like generally you do like this. So you do okay x, echo, cool. Does nim use, not nim, does it have commas for cases? It doesn't. Cool. Error x, echo error. Right, like this is a normal case. So if you want to simplify this, you could do okay x, echo cool, else echo error. Cool x, error x. Yeah. So this doesn't work here because you can't bind onto error. But you could do else case error x. Yeah, that's actually really clean. Holy moly. I might be able to go. Hold on. But it'll be like this. And then people won't book it on your new line at that point. But like that still simplifies it into like 4 lines of code, doesn't it? That's awesome. Let me actually ask this in the Discord server. This is quite something. case. It'd be hilarious if this is already supported, but I don't think it is. But yeah, so if it's true, then it just does that. Otherwise, the pattern matches it. So like there are two different cases technically, but I think it's fine. Okay, so there actually is support for Gleam on Discord, but not in my scene for some reason. Which is a bit annoying, but you do what you want to, Obsidian. This is how I'm working. Yeah, it'd be hilarious if this was already supported, but I don't think it is, because I sort of mentioned it. Also, about the recursion, I really dislike a language without loops, because I think that recursion is a far more difficult way to reason about iteration. Yeah. I think it fits really well, especially because the keyword is case. Right. Cool. Next. Tail calls. Okay. Why are you talking about this, dude? Like, just don't rely on recursion, please. When a function is called a new stack frame, do you know why we do tail call optimization? Do you know why? So that we can turn it into a loop. To store the arguments in local variables of the function. If lots of these frames are created during recursion, then the program will use a large amount of memory if you crash the program, blah, blah, blah. To avoid this problem, Gleam supports tail call optimization, which allows the stack frame for the current function to be reused for the function. Call is the last thing that function does, removing the memory cost. And do you know what this is called? Allowing the stack frame for the current function to be reused? It's called a loop. Just a normal loop, man. Why? Why? I find it ironic that tail call optimization literally exists to turn recursion into a normal loop. Why can't we just use loops? Optimize recursive functions can be returned to tail calls, blah, 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 using an accumulator. Accumulators should be hidden away from the users of your code. They are certain implementation details. To do this, write a public function that calls a recursive private function with initial accumulator for you. Dude, do you know how annoying it is as well to have to write this? Like, I hate doing this in Haskell, where I need to like just write this other version of my thing. Otherwise, we get stupid stuff like this. And like, look, you can, for the record, Haskell is an academic language created for experimentation purposes. I think particularly for, I think it was lazy evaluation was the reason it was created. Maybe something else as well. So like, do not take it as like, I mean, obviously it's not just Haskell, but like I'm saying that, don't take it as like a standard to use, you know, learn from it. But yeah, this just, it hurts me, bro. I hate this so much. I hate tail call. No, I hate recursion so much. Like maybe there are some particular instances where recursion can be good, but otherwise just don't. Please just use a loop where you can. Just use a loop where you can. I know that like it's technically gives you two ways to do the same thing, but like there really just isn't any excuse. Like it's list recursion. What is one? Okay. Times you may prefer to work with a list directly. Yeah, the first rest pattern matches on a list with at least one element assigning the first element to the variable first. Yeah. Okay, that's pretty standard. That's not anything special. By using this pattern and function for the empty list, a function can run code on each element of a list until the code is reached. It's weird that this language doesn't support like, you know, Haskell's some list on empty, some list on something, first rest. I find that kind of strange. It doesn't support that. Or even like OCaml with its function syntax, which does the same thing. So it would be like, well, there's no equal sign, so I guess it wouldn't really work like that, would it? So, yeah, this language is a bit like its intentions are very unclear. By using this pattern and a pattern, yeah, but the code sums a list by recursing over the list and adding each int to a total argument. Some list, yeah, calls itself, yeah, okay. I've seen that before. Multiple subjects, sometimes it's useful to pattern match on multiple values at the same time. In one case expression. Yeah, pretty cool. Ooh. Well, so I was going to say, for the shorthand syntax, you could also support that, but like, there's not really any reason to. Just use like an and for booleans. Yeah. While matching it, okay. Alternative patterns. Yeah, this is very cool. C++ is going to support this. Haskell doesn't support this, I don't think. Just as one example. But yeah, this is very cool. You cannot have nested alternative patterns currently, which is fair. I mean, like at some point the nesting just gets a bit ridiculous, and you probably should just avoid that and instead force the person to create a nested thing inside, which I know is verbose, but like at least you can wrap that in an anonymous function if you want to make things simpler. But yeah, like nesting patterns is probably not a good idea because it makes things unreadable. And that's like really when you are using functional programming features and like designs, you want to avoid things becoming unreadable because that can happen very easily. So like that is the main pitfall of functional programming, just things just being unreadable. So if you can avoid that and like find a way to integrate it without it being unreadable, you've done a great job. A great job. Let number equals at random. Yeah. Nothing new there. Pattern aliases. The as operator can be used to assign subpatterns to variables. Same as C++ too. The pattern as first will match any non-empty list and assign that list to the variable first. Huh? Why not just do this? Okay, that's not, so no, sorry. C++ uses this for types. This is just bad. This matches nothing. Is it because it's nested? Yes, right? So it's a list of lists. Yes, it is a list of lists, okay. It matches this as first. Okay, now that makes sense. Okay, yeah, fine, moving on. Guards. The if keyword can be used with case expressions to add a guard to the pattern. A guard is an expression that must evaluate to, sorry. This is like really fucky. Like this is where it starts to get unreadable territory, and where I would just expand this into its own case statement. So if I were to rewrite this, I'd do so like was it matching? A non-empty list inside. So it'd be like this. I mean, this should say list of lists, but whatever. That'll make it a bit more clear there. So then I just have this. And this. So this is matching an empty list, right? Yes. No. What? A list of empty lists. No, a list of lists, sorry. So if it's a list of an empty list, then you do rest. Interesting. How do you do this actually without nesting? Now I'm actually curious, because I assume it is possible, or else we are kind of fucked. Definitely here. But how do we get rest is the question. I guess just like this. Right? The case expression is of a pattern for all possible values. Okay. So if it's an empty list, then just do nothing, and it will catch it here. Did you mean lists? List 2 is on scope here. Yeah. Type mismatch. The type of this return value is not match return type by changing the function. Wanted list T, found type T. Where? Line 13, there are no line numbers, but okay, it's here, I think. This case clause is found due to return type different than the previous one. This whole thing is being treated as first. That's correct. So you return list 2. Yeah, and that works. Okay. So this is it with nesting. You could make the syntax a bit nicer by having this like directly match or something, but you can see how that just kind of make it a bit clearer. Oh, this isn't great. Okay. Something to think about, but it is an idea anyway. To avoid having like nesting of lists. Like, I mean, ideally you wouldn't get any deeper than a list of lists anyway. If you get a list of lists, then you have a problem, but yeah, I would just split it up. Okay. Probably should write that down, but I can't be bothered at this point. Guards, the if keyword can be used with case. Oh, so there's an if keyword. With case expressions, add a guard to a pattern. A guard is an expression that must evaluate true for the pattern to match. Okay, inside the if case. Guard expressions cannot contain function calls. Case expressions or control block. Oh, I can't read, or blocks. Okay. I'm guessing these don't have to be constants though, so this is that. If first isn't more than limit. So can I do case X add it here actually. Case 5. Okay, fine, whatever. Case 5 for X, if X is greater than 0, then return, what's echo, Yabol. Otherwise, do nothing. Yeah, that works. Got a warning, but actually, what is a warning? There's no need to pass dimensions value. Okay. Right, so yeah, this does work then. So you can have booleans inside, but obviously it's not much more less verbose. Cool. Yeah, cool. Okay, tuples. Lists are good for when we want a collection of one type, but sometimes you want to combine multiple values of different types. I don't like tuples because I would rather have named things. Yeah, they're a quick and convenient option, but also horrifically unreadable. The tuple access syntax, and like, it's another reason why Haskell is so hard to read, because it just uses tuples everywhere, and the function argument names are also really cryptic, and it just makes things hell. The tuple access syntax can be used to get onto a tuple, same as Rust. Tuples are generic types. They have type parameters for the types they contain, and they start with hashtags. Okay, bit weird. I don't know why they don't just use angled brackets. I guess because this is a thing, but like just use a different operator, please, if that's such an issue. Tuples are most commonly used to return two or three values from a function. Often it is clear to use a custom type where a tuple could be used. Yes, we will cover custom types next. Okay, I'm glad they acknowledge that. Custom types. Here you go, finally. Pub type, season, spring, or chicken. That's an enum, right? Gleam has a few built-in types such as int and string, but custom types are the creation of entirely new types. Type keyword followed by the name of the type and a constructor of each variant of the type. Both the type, name of the types, names of the constructors start with uppercase letters. Can they contain data? Echo, weather, spring. Yeah, they can then. Cool. Okay, so yeah, so they're type unions, except not cool because where are the names? Records. Okay, there are names, thank you God. But they're optional. So named tuples are optional. A variant of a custom type can hold other data within it. In this case, a variant is called a record. The fields of a record can be given labels, and like function argument labels, they can be optionally used in calling the record constructor. Typically, labels will be used for variants that define them. I do like the idea of unifying this syntax with function call syntax. I will say that. But this common to have a custom type with one variant that holds data. That is a equivalent of a structure object in other languages. Okay. I mean, it's quite convenient. It means that you can very easily turn this into a tagged union, which is probably not a good thing, actually. Never mind. When defining custom types with one variant, the single variant is often named. Yeah, there's more I could say on this, but it's too deep. I'm just gonna skip it. Record accessors. .name, .pseudoname. Yes. Okay, here's treated as a module name, which is really weird. Okay, so this wouldn't work, obviously, but I can do teacher.subject, right? Yeah, Mrs. Schofield. Kushar. Yeah, I should like how this mirrors module access. It's why I prefer this for module access, you know? So that's important. Record accessors. This highlights a reason to use : for namespace for module access rather than using dot that you would expect for variable for struct access, since with this code is teacher a module and name or a struct. Well, or a record in this case. Even the syntax highlighter on the website highlights it the same as it would a module, even though teacher is a record instance. You could argue that the distinction does not matter, but then why do we have modules in the first place? Why do we not just use modules instead of records? Or vice versa? Why not just have records and discard namespaces altogether? Well, module namespacing. Okay. Next. How far am I, by the way? Contents. I'm getting towards the end, actually. Well, yeah, kind of. Where was I? Record, pattern matching. It's possible to pattern match on a record. This allows for the extraction of multiple field values from a record into distinct variables. The let keyword can only match on a single variant custom type or when the variant is known, such as after pattern matching with a case expression. You cannot use underscore or whatever. Okay, so where's this? Case fish, which is a jelly. No, what is this? Handle fish, six of fish, and matches on it. Yeah, sorry. Starfish, favorite color. I thought you said you can't use this. Oh no, sorry, it is possible. Sorry, I misread. Dot can be for any fields. Sure. Favorite color. Does order matter, I wonder? Maybe not. I assume I can also do this, right? No, not really. No, never mind. I could elaborate, but just never mind. Handle ice cream. Yeah, okay. Pretty standard. This thing. Yeah, seems like some, like I was talking about before, right? So that would work. Like Rust. I had a thought. What was it? Maybe not. Okay. Record updates. Oh, that's right, the functions. God forbid you get fish.handle. I don't know, man. Like, just where are my objects, you know? So yeah, I'm probably not gonna use Gleam, I'm afraid, because I really appreciate having dot syntax, man. Record updates. The record update syntax can be used to create a new record from an existing one of the same type, but with some fields changed. Gleam is not an immutable language, so so using the record's update syntax does not mutate or otherwise change the original record. Yeah, so no mutation. That's starting to sink in. Right, so you pass .teacher1 and then that does it. I mean, yeah, fair enough, I guess. It is a convenient way to copy something and then change it. Yeah. How would you do this in C, in Haskell even? I don't even know. But that's pretty cool. And it's even useful outside of functional context. I mean, I don't know why it's dot teacher and not just like something else, but it works. This is a pretty nifty syntax for copying a struct and then modifying specific members. Although I wouldn't use ... because I'm not sure how that operator is. Yeah, I mean, it's just kind of overusing it. Like teacher from teacher one with or something like that, you know, like, I mean, probably not, because that's like horrifically verbose, but just something else. Also, how do I get my LSP to support this? Or like my thing to support it, because it doesn't work here. And I mark this as Gleam, but it's not. Let's mark it as C. Whoops. Where the fuck did I go? Should be there. Okay. Cool. Generic custom types, like functions, custom types could be generic. Sorry. Oh, okay. Here, a generic option type is defined. Yep, same as Rust, really, just without the Angular braces, right? Options, some, none. Nil is Gleam's unit type. I thought it said there was no null. It is... Yeah, so it's a unit type, but why not just call it unit or something instead of nil? Or like void. Nil is not a value of any other types. Therefore, values in Gleam are not nullable. Oops, the type of a value is nil. Then it is the value nil. That's a confusing way to phrase it. If it, I mean, I guess that's how it's implemented behind the scenes. I don't know, and that's why they present it like this. But it's kind of funky. If it is some other type, then the value is not nil. Uncomment the line that assigns nil to a variable with an incompatible type annotation. I don't need to do that because I already know. But it's a value, and so can I do this then? Is that what it's implying? Yeah, so nil is both a type and a value, which is kind of fucked. But sure. I actually don't much to say on that. It's just weird. Gleam doesn't use exceptions. Instead, computations that can either succeed or fail. Hold on. Let me actually think. What? Found type bool. But it echoes it. That's not the same thing. Why does this have a return type of... Okay, that is actually broken then. Why is this bool? That doesn't make sense. Huh? Found type bool. Okay, that's fucked. I mean, you're defining main, to be fair. Why does that work? Why is that? Okay, yeah, that is just broken. There's no way that should be happening. Okay, so that's a weird bug. I don't see how that could be a feature. For some reason, nil is used instead of void. Funky naming, if you ask me. Nil is also a value, so you can have let x of type nil equals nil. I'm not a fan of this either. Like, I get that, like, you need something for functional programming. In other languages, this just isn't a thing. And, like, you can't assign nil to this. Again, you kind of have to functional programming. I get why it's kind of necessary for an expression-based language, but I wouldn't include it in a normal language. Even then, is it necessary? I don't know. Like in Haskell, can I do let? Like, can I? I don't think I can do that. Can I? Let me try something. If I'm in Haskell and I want to do main equals do x from print hello. Last statement must be an expression. Okay, print world. That works, I guess. Yeah. Like, what is the type of x? Can I print x? Yeah. So x has a value of that too, I guess. Okay. Note, Haskell does the same. Just try running this code. Main equals do x unwrap print hello. Doesn't matter what you print, to be fair. Print x. You don't need to print anyway, but bro, I love this font so much. Like low key, high key even. Goated font. I don't love this though. I wish they would fix this thing so I could have like indented, but okay. Results. Gleam doesn't use exceptions. Instead, computations that can either succeed or fail return a value of the built-in result type. Is it just built-in? It is. And then what do you match on? Error and OK. Okay. This type is generic for T-type parameters. Commonly, a Gleam program library will define a custom type with a variant for each possible problem that can arise. Okay, like Rust, I guess. This is advantageous. Yep. Result value could be handled by pattern matching. Yep. Okay, this is nothing new. Bit arrays can represent. They do represent a sequence of ones and zeros. Oh, holy moly! We finally got angled brackets, and they're used doubly. What the fuck? What? We got bit arrays before arrays, or these arrays. Okay. Why are we even like introducing binary data when the language isn't a systems language? Or like, why is it such a built-in syntax? 8-bit int. I'm kind of speechless. Why is it called a bit array? Can I have like 7 bits? What? Yes. What? What? Each segment of a bit array can be given options to specify the representation used for that segment. Multiple options can be given to a segment by separating each with it. This is really weird syntax. This is really random to just throw in the language. That we just have properties now. Out of like nowhere. Bit arrays can have limited support when combined to JavaScript, and all options can be useful. Right, so it's specifically because Erlang supported it. That's really weird, but okay. I'm just gonna gloss past that. The Gleam Center library pack is a regular Gleam package that has been published to the Hex package repository. What's Hex? For Erlang in general. Elixir, Erlang, and Gleam. Cool. I like that Gleam is officially recognized. Whether I don't know why you'd use Gleam. All the modules imported so far in this guide are from the Center library. All the documentation for the library is available on Hexdoc, so I'll go over some of the most commonly used modules now. Sure thing. The list module gives you list functions. Okay. Yet you can still use lists without importing list, which is a bit funky. Just another module thing. Okay, looks normal. Result module. Try. Okay, so you got like your bind. No, not really a bind, but you got your try. And unwrap. And map. Dict. Is this a map? Yeah, keys and values. So you got a map, probably a hash map. From list. Okay. Ooh, hold on, what's this? Yeah, piping is cool for this. Although it's also like horrifically slow because you're creating a copy each time. Obviously the compiler could optimize this, but like the way it reads just isn't right. Option module, type option non-sum. Do I have to do that? Well, I can just do option dot. Wait, why is option isn't built in, but result is, which is really, that's weird. Yeah, that is weird actually. Option module, I find it strange that results is built into the language, but option has to be imported from the standard library. Okay. Opaque types are types with a custom type where a custom type is public and can be used by other modules. But the constructors for the type are private and can only be used by the module that defines the type. This prevents other modules from constructing or pattern matching on the type. This exists already, I think. Like it's not a new concept, but it's not something I've come across much. Wait, it's actually called opaque. Huh? Sorry, smart constructors. A smart constructor is a function that constructs a value of a type, but is more restrictive. Right, so it's like a way of having public and private member fields, I guess. But you can still access the private fields, so it's more just having non-settable fields. This is such a functional programming issue. Like, what the hell? If anything, bro, just For example, this positive, okay, next. Use, Gleam likes exceptions, macros, type classes, it'll return, no type classes. Fuck, man. What is the point in this language? I'm actually curious. What is the point in this language? Because I don't understand. It's literally just, so far, it's seeming like just a worse existing functional programming language. Like, is Elixir even, like, is it, I don't know. And a variety of other features, instead of going all in with just first class functions and pattern matching. Okay, I thought it was use. It's talking about the use. So good. My question's being answered now. This makes Gleam code easier to understand, but it can sometimes result in excessive indentation. I guess so. Can you can't speak. Can you not just use piping here? I thought the whole point of piping was to reduce indentation. Can you? Hold on. Without use, get username, get password. Like, I can't speak. Can I not just do this? Log in, username, password, pipe, result.map, with a function greeting, which is greeting onto username. Then pipe that into result.map get password. And then pipe that onto results.try. Sorry, it should be try. Get username. Found this instead of this. Username is not in scope here. Where are username and password coming from? I don't understand this code. Where are username and password coming from? From these. And it returns a function. So I should probably pipe it like this then instead. So it's a function, username, password. No. I'm very confused here. I want to abandon this, but I just wonder if there's a way to pipe that instead. Oh fuck! It actually is the use expression. Bruh. I thought it was talking about the language's use. Oh my god! I got right. So this is how you simplify it. Okay. Right. Okay. Gleam's expression is for calling functions that take a callback as an argument without increasing the indentation of the code. Very cool. Yeah. All the code below the use becomes an anonymous function. Yeah, so this is weird. So all the code here is an anonymous function that is passed to this. So it's like it's kind of like piping in a way, but also not really. And the assigned variables that become the arguments of this anonymous function. So this code expands into this code, which is kind of hard to wrap your head around. So, I mean, I still don't understand what's happening here. That's the issue. Like get username. Okay, fine. Get password. Log in with those, greeting, then you get this. What's this doing? Get username into function username. What does try even do? Tries this. Then gets this. Right? So it's like get username. And then pipe that into results.try function username. Yeah, no, I can't think of a way to deal with pipe syntax properly. Okay. But the way it does it is interesting. I want to make sure I actually understand this. So it passes all of this into this. So this will just encapsulate this code here. And then that's the username variable. Yeah. Man, this actually hurts my head. In Haskell, I would do results.try get username. This operator, the bind operator, into an anonymous function username, and then the rest of the code. So that's what this does basically. And with do syntax, it would be username, boom, boom, same thing. Yeah. So it's like Haskell. That's okay, because like I asked this guy in the C++ Discord server if it was like the Haskell thingy, and he said no, but I'm pretty sure it is, because like this becomes the function body for everything else. Like that's how Haskell works. So then you do results.try get password, and you can bind onto that as well. So you get /password, the result.map, login, username and password because those are in scope. Bind that as well into greeting, and then whatever, greeting plus boom plus username. Like that is the same thing in Haskell. This just uses the do syntax. So it'd be like username, this, result.try, get username. Yeah. I wonder why it even needs the use keyword in the first place, but okay. So it's like Haskell. And if you just write this in a more functional way, it'd be like this. You probably just call it username because it's no arguments. But at that point, like, what even doing? Ooh, yeah. So I guess the main difference would probably be the function type, I'm guessing. Oh, maybe not though. Yeah, maybe not. Because like, well, in Haskell, like the type of the function needs to match. Here's the no, yeah. I'm pretty sure it is the same then. Let me ask this in this. Okay, Discord. You can reload if you want to. Would be either string or nothing. Let me try compiling this with the bot. Okay. I mean, these aren't real things though, and these functions don't exist. Okay, fuck it. I won't compile it. Oh, wait, nope, down. No, you can't eat that. My brother just left mince out, so obviously the cat's gonna try and get at it. They should have greeting. Okay. To ensure that your use code works and is as understandable as possible, the right-hand side ideally should be a regular function call rather than a more complex expression. Like this, which should be more difficult to read. This is a very capable and useful feature, but excessive application of use may result in unclear code, especially to beginners. Usually the regular function call syntax results in more pushable code. Okay. To do keyword is used to specify that some code is not yet implemented. Sure. The as some string is optional, though you may wish to include the message if you have more than one block. Yep. I mean, I think Rust has the to-do macro, right? The panic keyword is similar to the to-do keyword, but it is used to crash a program when the program has reached a point that should never be reached. Dude, anything but type classes or like traits or like even like balance checking, dude. I don't like that. Can you panic without a reason? You can. I mean, I like to like unreachable or something, you know. If score can never be negative, because like how do you enforce this? Yeah, I don't know, man. Should never be used. It may be useful in initial prototypes and scripts. Basically, how do you not let this be negative then? The type system can be used to make these invalid type states unrepresentable. How? It hasn't yet shown a way where you can make a type unrepresentable. Can you show how that's possible, please? Assert. No, this is like panicking. Let's say something to learn that it's a way to assign values to variables, but it's different in the pattern, can be partial. Okay, just like panicking to do, the as keyword can be used with let assert to supply a custom panic message if the pattern fails to match and the program crashes. And it shouldn't be used. What the fuck? So why is it in the library, man? So let assert score as score. Sorry, if score is less than 0. I messed this up. What I want. Never mind. Funky ass syntax. Bool assert. It asserts that a Boolean value is true. Okay. Externals. But like, I don't understand how the type system can do that. I don't understand. Can you tell me? Gleam says not to use panic or assert. But then how do I make certain states unrepresentable? For example, how do I prevent a function from taking a negative integer? Am I stupid, or do I not see how this is? Oh, it's here. Okay, so it uses what do you call this? It uses result type. Okay, that's fine. But also, like, there's got to be a nice way to do this that I like to see explored. Externals, yeah, okay. A external type is one that has no constructors. Gleam doesn't know what shape it has, how to create one. It only knows that it exists. Whereas it's like, okay. But then how do you use date time? And you can provide type annotations, okay? Gleam trusts that the type given is correct, so an inaccurate type annotation can result in UB. Oh no. And crashes at runtime. Be careful. Don't want to look in there. Be careful. Assertive functions are useful but should be used sparingly. Prefer to write Gleam code where possible. Oh shit. That's not a good thing. Multi-target externals. Multiple external implementations can be specified for the same function. Okay, so this has to be your language JavaScript. Can I do something else? If a function doesn't have an implementation for the currently compiled for target, then the compiler will return an error. You should try to implement functions for all targets, but this isn't always possible due to incompatibilities in how IO and currency works in Erlang and JavaScript. Okay, whatever. External Gleam fallbacks. Interesting. So here it only evaluates this if this fails, which is really dodgy. It's kind of unclear, but okay, next. What's next? I'm done. Read the Writing Gleam guide. Join the Discord server. Enroll in the Gleam track. Exorcism. And Code Crafters. Developing Gleam project. Okay, I'm gonna stop there. That was Gleam. Let's have a look at what I had to say about it. So, as a recap, I suppose. Make sure my things. 3 hours, Jesus Christ. It's strange to me that a language support import module. Yeah, so that's weird. Unqualified imports, type checking. Yeah, agri keyword is cool. That's okay. So let's say about that. Ints. Yeah, that's cool that it's capitalized. Floats. I don't know why they have two separate types if you can't even have more specific integers and floats. I don't know why that needs to be a thing. I guess you just enforce like. No, integers anyway. Wait. Down. Come on. No, get down. Down. What are you doing? Blood. No. Down. Come on. Down. They have food. Discard patterns. Yeah, that's weird. Type imports. This I don't like. I'd much prefer if the language just had objects properly. Like people treat functional programming like it's incompatible with having just like fucking good object syntax. It isn't. Please, for the love of God. I think OCaml. I mean, even OCaml doesn't do a great job with that. Type aliases. Yeah. Okay. I don't understand what. Yeah. Just a question there. Blocks. Don't like how you throw it at the end, like in Rust. I do like how it can be used for closing sub expressions though. That's really cool. And you could also technically use it for anonymous functions in a way, except I guess they're ones that are immediately executed though. So fair enough. Captures is a cool concept. Pipelines with the function capture syntax is also honestly perfect. I think this is really good. Would love to see this in a language. Probably Gleam's strongest combination of features that I got from this tutorial. Labeled arguments, not so great. Shorthand, mildly cool, not particularly important though. Case expressions, yeah. So in particular, I think case expressions could be really powerful if they adopted this syntax. But that's an if. So one could only dream. Otherwise, yeah, like if I was to make a language, I think I would actually probably adopt the syntax because I like it. And then you don't need if statements. So I think that'd be pretty cool. Like I think this is the best idea I've taken away from this as well. Record accessors. Yeah, I mean this is debatable, but I do agree with having double colon or something to access namespaces or modules. Or even like static classes, but that's not even supported in this language, so whatever. Record updates, pretty cool. Would use a different operator for that, but pretty cool. Nil is just weird. It's a functional thing. It's just weird. I wouldn't call it nil, but it doesn't really matter at the end of the day, does it? And then option module, that's weird. So yeah, I mean, more negatives than positives, that's for sure. The positives, I mean, the reason why they're lacking is because a lot of the things that are good about the language are things that are already in other languages. So those are neutral anyway, because it's like, yeah, like I don't, my ultimate question from this is who and what is Gleam for? Because it doesn't seem like it would be a good substitute for JavaScript. Because JavaScript, like if you want a better JavaScript, use TypeScript or some other functional language if you really want a functional language for JavaScript that is more featureful. Like this one doesn't even support type classes, so like Haskell is really better in that regard. And like if you like functional programming, you probably prefer functional programming syntax anyway. Like Gleam might be someone's introduction to functional programming, kind of like how Rust might be, but it just lacks like a lot of the good features that would make it a proper introduction. Yeah, like it just seems really limited. I don't understand. And because it doesn't have traits, I assume JavaScript has classes and inheritance and interfaces. So like, how's it going to make up for that? It'd just be kind of limited, I feel. Yeah, I've never used Elixir, and that's functional, so I don't know how Elixir differs from Gleam. In fact, let's do a quick search because I'm curious. Elixir versus Gleam. Elixir's type system is structural. Gleam's system is nominal. Elixir's types can be more precise in some respects, but it can't distinguish between types that are semantically distinct but structurally the same. I see. That's weird. I mean, that's fine though. This is a form on the Gleam profile. Okay. Let's look at this then. This is on the Gleam lang. Oh, they're asking a question. Okay. We're not competing, we collaborate. That's fine, but there's still different languages, so. Yep. Okay. Yeah, but they are competing. If they have different user bases, then they are competing to appeal to different users. Like, just because you're not getting the same users doesn't mean because like obviously, if you have two competing languages, people when they first enter this space, like all that means is that like Gleam is failing to capture Elixir users and is instead capturing new users, which could just mean that the language is worse than Elixir to the point where Elixir programmers don't care, and then new programmers are getting, yeah, okay, yes. So then the only user base is new programmers. That doesn't mean that the new programmers would prefer Gleam if they had used Elixir before, because then you get like survivorship bias where the current Gleam users are those who still use Gleam. Those who left Gleam or never use Gleam or like never use Gleam are not being considered. So no, dear brother. Yeah, I don't know, man. I'm really confused on why this language exists. But hey, at least it exists, right? At least we can do this. That's nice. I'm really curious if function captures, as I think it's called, is used in any other languages. I would assume, maybe, yeah, let me look it up. Are Gleam function captures used in a novel, or have they existed before? The ML family 1970s. Oh, Haskell has it too. Borrowed from Scala. Well, shit. Bro, I gotta try Scala out. Like, only today I learned about Scala, and I'm very, because like I didn't know that it was, first of all, I didn't know it was functional. Second of all, I didn't know that it was for Java, like you use JVM, so that's really cool. Let me have a quick look at that. I was here. I'm very curious to try out Scalar. Because it's object oriented and it's functional. It has traits though, which is really cool. So that's really a plus. And it has classes. Does it even mention inheritance? Maybe it doesn't even have inheritance. It has class compositions with mix-ins. That's pretty cool. Type inference operators, yeah. So like, I really want to have a look at Scalar. The Scalar 2 in Thea, by the way, as well. But look at that. Scalar 2 use this. Scalar 3, simplify the syntax. Awesome. So yeah, I think I'll look into Scalar in the future. But anyway, that's Scalar. Yeah, so I just realized I wasn't sharing my screen. Here's Scalar. Boom. But yeah, so I borrowed that from Scalar 2. And it's a nicer ergonomic over Elixir's one, but Elixir has the same thing too. Wait, so Elixir also has the same thing. So like the one feature that is like particularly cool about this language isn't even unique to this language. In fact, it's so not unique to the language that the competitor in the same space uses the same syntax. Okay, who is Gleam actually for? Considering Elixir exists for FP, Erlang also exists, and JavaScript also exists. I don't understand. And JavaScript and its variants also exist. Specific. People who want the beam concurrency and a strong static type system. Elixir and Erlang are dynamically typed. You get fault tolerance and distribution, but no compile time type safety. I see. Okay. That's interesting. But Gleam's types are very general anyway. There is only int, float, bool, and string. No type classes, no HKTs, but it's still a proper Hindley-Milner system with a full inference. What is a Hindley-Milner system? I need to read up on that as well. The power comes from custom types, pattern matching, lots of sprawling built-in type hierarchy. Okay. I mean, that's fine. It just seems very primitive. Like, they could do a lot more with it. And maybe they will. I don't know. When was Gleam created? I feel like they could expand it much further to make it a much more powerful language. Please be like 2020s. Close enough. 2016, 2019, and then version 1 dropped 2 years ago. It's meant to be a simple, small service area. The bet is that simplicity plus Beam is more valuable than feature richness. Adding more features would push it towards Haskell and Scala, at which point, don't bother. Okay, dude, whatever. I don't know. I mean, if you haven't used this language, then go ahead and tell me in the comments below. But like, I don't know. I'm also not sharing my screen. This is what Claude said. I don't understand why you would do this. I don't understand. Like, it seems like it's kind of niche, but like, why would you learn this language and then use it and not just use a more powerful language, which would give you more general usage anyway? Maybe you particularly like the syntax. But you know what? If it works for your projects, it works for your projects, you know. That's always been the main thing. It's just interesting. Yeah, I guess people are just comfortable with what they're comfortable with. And if they don't have a reason to switch, they won't switch. Hey, you know what? Can't argue with that, really. It's fair. Okay. Cool. So, my final analysis of Gleam, I don't know, like a 4 out of 10. I mean, it's just not very interesting, is what I get from this. Like, pipe syntax I've seen before. The function capturing thing is not only kind of confusingly named, because I'm used to that being something else, but also the syntax isn't even unique to the language. It just happens that this is the first time I've seen it. And yeah, I don't know what else to say about this language. There's like a bunch of negatives I can say about it, but I don't really want to dog on it any more than I already have. So cool. Gleam is a language that exists. Thanks for watching. Man, yeah. I will. For my upcoming videos, by the way, I will. I want to tap into this. Let me show a bit of a sneak peek. Like last night, I was lying in bed, and I was working on this post here. Not post. This list. These notes, I guess, where I wanted to look at how machine code and human high-level code differs. To like kind of find ways that things can be unified. Like for a very quick example, variables, right? And I tested this. If int b is in the global scope and int a is in a local scope, and then I have a be a reference to b, b be a reference to a, but then a goes out of scope, guess what happens? B is completely fine. The variable is still in scope because a just becomes an alias. B becomes an alias for a essentially, to the point that even if a goes out of scope, b still carries it on. So that's really weird to me. It's kind of a weird quirk of C and C++, and it makes me think, for example, what if instead then we just had variables be, if rather than having a reference to a variable, you just have the same variable but with a different name. So then we put more emphasis on the address space, and I think that'd be quite interesting. So that's one such feature, that idea that comes from that kind of analysis. So I want to kind of focus on those a bit more, and then hopefully that will help me progress towards designing my own programming language and then eventually implementing it. I do need to continue doing RS locks, which is my locks implementation in Rust. I will continue with that eventually, but for now, my motivation isn't that strong to do it because I don't have a programming language in mind anyway. But I'll finish it at some point. I'm just going to get around to it. And my C++ library is it's a thing. I think it's bugged right now because the debugging for it is just really not good. I tried using errors as values, but even then, you get no stack trace or anything, so it's really just not useful. And I you kind of need reflection to make that work, to the point where using exceptions honestly would be better. So that also really sucks. So I want to research if there are ways where I can make it better, the debugging better, and see what I can do there. But I worry that it's going to be really verbose. So that's another thing there. Also, I need to get around to implementing the same library in Rust, because I'm going to go all in on Rust. Not all in on Rust, but I want to commit to Rust as a serious language, because there aren't really any better alternatives. I looked at Zig for a bit. I didn't use it, but the more I hear about Zig, the more I'm disillusioned that it's a good future-proof option. I think it doesn't scale well, and it just lacks useful features that come with object-oriented programming, or just objects in general, and inheritance and traits, and things that Zig just doesn't have for some reason. Because I guess I want to keep things simple and control flow simple, but those things just aren't good enough. We can do better. So yeah, these are all things I want to revisit in the future, and I will. So subscribe if you want to see those, and I will conclude this 3.5-hour recording. But yeah, if you want to check out Gleam, I've linked it in the description. And again, if you watch this far or skip to the end or whatever, and you've used Gleam yourself and you have any thoughts on what my thoughts are, then let me know. Or if you have never used Gleam and you also watch this video and you think it's interesting, and have some thoughts about it, then let me know as well, because I'd be very interested to hear. Maybe even join my Discord server, and we could talk about it. I will not be joining the Gleam Discord server because I have nothing to say about it. Really, just criticisms that I feel like will not be welcome. So I might write a blog post instead, and see how, I like post it on like the Reddit or something. I don't know. We'll see. But yeah, thanks for watching.